And we're back. This is part 3. All right, so the possible inflection point. So that's what we need to investigate. So we're looking at it, and we want to check and make sure, again, to the left it's one thing, and to the right it's the other, like we did before. So negative to the left and positive to the right means that it is an inflection. Now, if you were to get concave up and concave up on both sides, we wouldn't consider that an inflection point. So like if our second derivative was positive on both sides or negative on both sides, we would not say that that's a particular inflection point. But because it changes from negative to positive, excuse me, we'd say it's an inflection point. And that'd be how you'd explain it. So AP test, right? I know there's an inflection point because the second derivative changes from negative to positive, or you could say from positive to negative. Okay, I can't quite see with that recorder. What's that mean? Hold on. Okay, so that first line, right, we have x and y, so that's our point, -1, 0. And then y prime is positive, so that tells us it's rising, and y double prime is negative, telling us that it's going to be concave down. Let's see, I'm trying to switch back and forth from these. So there's our point. And here's our second one. So at 0, our function is 4, and y prime was 0. So it changes from, that's going to be our local max. See up there at 0, 4. And then at 1, 2, we have, it's a negative slope, and double prime is 0. So that's our inflection point. So notice that, like, if you look at the slope, y prime, that 9, 0, -3, it's going positive, then it's 0, then it's negative. So that's, again, how we know it's maximum. Or if you look at just the 9, or excuse me, just the 0 and the -6. Because the slope is 0, it could be a maximum in, and then because it's negative, it's inflecting down. Are you with us? I want to say your name to put you on the video. Someone in class was a little spaced out. We're not going to name them for the video. All right. So again, notice that when we get to 2, 0, that's a point. We can tell it's a local minimum, even if we don't know the slope on both sides, right? How am I telling it's a local minimum? Second derivative is positive, which means it's concave in which direction? Concave up. All right, so that's the 0 slope, and it's concave up. All right, and then this last point, 3, 4, we have a positive slope and positive second derivative, so it's rising and it's concave up. And then we could try and connect those with like a smooth line to get our graph. Wasn't it? Yeah. Okay, here we go. Yeah. I'm sure if you draw these in pencil, it's going to be just as nice as this. That's the end. Okay, so you can watch this many times if you have questions.